Okay, so today is logs day one, and you will understand how logs work. You're going to actually be pretty good at them. We are actually going to use a calculator to understand them a little bit better, but I am not going to be encouraging you to do all your logs in the calculator at all. I just want you to see how the calculator can be used to get basic ones. And logs are good for things like decibels, things like the pH scale, things where there's a huge range and you can simplify it down to a simple like 1 to 10 scale, or in this case a 1 or a 0 to 14 scale. Another big one is the Richter scale. How many of you guys have heard of the Richter scale before? Okay, good. So if you had a earthquake in your neighborhood, by the way, you might think, wow, we don't have any in Minnesota. We're on a fault line. It's just hasn't been active in a long time. But Minnesota and in Twin Cities here, this is on a fault line. The San Andreas fault, have you heard of that one? That's the big one that's really active right now. But ours used to be active, but we're talking a long time ago. So could it possibly start back up again?
Yes.
Absolutely. So, and here's another interesting note. Pretty much nobody has insurance for that. Your home insurance doesn't cover earthquake. I know because I do insurance. If you buy special earthquake insurance, you can buy it. And in fact, it'd be pretty cheap because, you know, nobody has earthquakes around here. You'd look like a genius if all of a sudden an earthquake happened and you were the only guy in the neighborhood who had earthquake insurance. So if you live in California, a lot of people have not only homeowners insurance, but special earthquake insurance. It's separate. And you can buy it, and it's not cheap because if an earthquake happens and it like shakes your house bad enough to like crack the foundation and stuff, a lot of times you just have to rebuild the thing. So it's really expensive to have. But if you live in San Francisco, for instance, and you have like a $1.2 million house, do you really want to not have any insurance if it falls over? That's kind of risky to not have any insurance for it. So anyway, something that we don't worry about, but one day it just could happen. All of a sudden, it could be a massive earthquake, and like everybody's house gets damaged, and nobody has insurance for it. Just an interesting thought. All right, so the Richter scale, if you had a 2.8 earthquake here, and your friend had a 3.8 earthquake in his area, he lives in California or whatever, well, obviously 3.8 is bigger than 2.8, right? But the thing that most people don't know is it's 10 times bigger. Go up 1 on the Richter scale, and it's actually 1 power of 10, as in 10 times bigger. So if you hear about an 8 on the Richter scale and you think that's a pretty big one, and it is, okay, you go to a 9 and you think it's just a little worse. No, a 9 is 10 times bigger than an 8. So this just compare like a 5 and a 9. The first jump is from 5 to 6, and that's 10 times bigger. The next jump is from 6 to 7, and that's 10 times bigger. So 10 times 10 is 100. And then times 10 again, 1,000. And then times 10 again, 10,000 times bigger. Because every jump up is times 10. All right, so a 5 compared to a 9, 10,000 times stronger. All right. So the Richter scale is kind of cool because it can take something that's so faint, like if you had an earthquake of 2.0, you might, if you were paying attention, notice it. They're super, like, you know, like not violent, the like under 2s. You can't even feel them. So then it goes 10 times bigger from a 2 to a 3, and now you can feel it. And then from 3 to a 4, now you're definitely feeling there's starts to be some damage to things. 4 to a 5, etc. And the big one they're worried about is a 10. It's never been a 10, but a earthquake. You can imagine if the worst earthquakes that we've ever had have been like, I can't remember exactly. 9.2 sounds familiar. If a 9.2 is the biggest we've ever had, then can you imagine if the worst ever got multiplied by 10? Holy cow.
It says 9.5 in Chile.
Okay. Apparently it was one in 9.5 in Chile. Yes? You'd have to look them up. I don't know. The one in Haiti was obviously pretty bad too, but especially because the houses weren't built to the standards that can handle earthquakes. And nowadays, cities require people when they're building in areas that have earthquakes, they require them to have like certain like standards on how thick the walls have to be how strong. And there's actually the biggest skyscrapers, did you know, are built on rollers. They have big rollers in the basement so that the whole building can roll side to side. That way, if it starts shaking, the building can kind of wiggle back and forth without breaking. They actually just kind of flex. The steel can bend and flex, and the building can remain upright. Obviously, if it doesn't, and you have a big building like the World Trade Centers, you saw what kind of massive damage happened 9/11 when the World Trade Centers came down. That came down because of a terrorist act, but what if it was a earthquake? Obviously, you could still have massive injuries and deaths and pretty tragic. So they make people design their buildings to handle earthquakes, but they don't make them handle a 10. The standards aren't that high because it's never even happened. So can you imagine if there was an earthquake magnitude 10 in San Francisco? Massive city, all those buildings, the buildings couldn't handle it, and there'll be all those buildings falling over. It'd be incredibly awful, and that's why they say that you know, if that day ever comes, it's going to be just terrible. Okay, so anyway, the Richter scale is another thing that's based on logs. So I wanted to give you some reason why logs are actually something useful you actually use. You see them in the news, etc. And it comes down to this. You know how to solve this. You just subtract 2 from both sides, right? You know how to solve this, you just divide by 2. You know how to solve that even. It's a little more complicated, but what do? Square root. You square root both sides, or you can put it to the 1/2 power, which is the same thing. But you don't know how to fix that algebraically. Now, you could graph both sides and see where they cross, but you don't have the tools yet, which is logs, that solve those. And that's what I need to show you. In fact, I'm going to just tell you right now how to fix this and get the x alone. You rewrite it as a log. So I say log, and then I have to pick a base for my log. It's a little subscript number that goes down here. Now think about it. Of these 3 choices, 2 or x or 7, which one seems logical as a base? 2. Because it's the base right now with an exponent on it. So it's the logical choice. The 2 is the base. Now this next part does not kind of follow logically, because if you were going to do it logically, you'd probably want to just do it in order and say first is the 2, the next is the x, and the last is the 7. I wish it was that easy, but it's not. You have to alternate back and forth. If you start on the left side of the equation, the next thing you do is go to the right side of the equation. And then the last thing you do is come back to the left side of the equation. There, I rewrote it as a log. And why is it good? Because the whole point of solving is to get the x alone, and I got the x alone, didn't I? Now, how do you actually put that in a calculator? Most of your calculators are not new enough to be able to put in a base 2, but I can show you the shortcut then. Everybody grab your graphing calculator if you have one, and type in log 7, and I know that's a little counterintuitive because you're thinking, isn't the 2 first? Can't put it in that way though. Log 7, and then it has a parentheses like this. You got to end the parenthesis. There, you've done log 7. Now, you type in divided by log 2. And you get a decimal. Hi, would you read me that, please? Log 7 divided by log 2 comes out to 1 point. I guess it can be anybody. You got it? This is 2.807. All right. So what is that? If I put 2 to the power of 2.807, it'll equal 7. Or it'll equal like 6.99999. How come it doesn't hit exactly? Because you didn't give me the whole decimal. See what I mean? If you gave me the whole decimal all the way out, it actually would hit exactly 7. But this is rounded right here. You stopped because you didn't want to read me decimals forever, right? So that's why it doesn't always hit exactly 7. That make sense? All right, so that's a log, and that's why we need them, because algebraically we had a way to solve all these other things to get the x's alone. We didn't have a way to get the x alone there. Graph both sides, see where they cross would have told us the answer, but it's not a way to get x alone algebraically. Yes? There was a hint of that, and a lot of times our R4s that we have are kind of a hint of the future. It's like, if you can handle this one, then you'll know what we're doing in our next unit. In other words, the R4s are supposed to be stuff we didn't teach you. Like, can you go beyond what we even taught you? That's why they're tough. That was a little too tough, to be honest, though, because, again, I didn't have many people get the R4 right this time. Almost, I think one person did, and I was like, whoa! And then the really sad part was that they hadn't gotten an A, and therefore it didn't even count. So, again, my opinion on this, I'm willing to say this on the recording, is that we should just add 5% to anybody's score who gets that thing right. But not everybody agrees with me on that. So anyway, back to 2.807. It came from doing log calculation on your calculator. But you don't need your calculator to do a lot of logs. A lot of logs can be done in your head if you know what you're doing. But it boils down to getting the bases the same. We did this before. Do you remember how to write 32 as a 2 to the something? 2 to the 5th. And if it's 2 to the 5th, then my bases are the same, and then x has to equal 5. Remember doing those? Just real quick, answer the other three. Make the bases the same, then the exponents have to be equal, and do a quick little calculation, and you should be able to solve all of those. I'm going to pause for a second. While you make all those bases the same, personally, I would make this 9 into a 3 squared so that I can make my 1/3 into a 3 to the something, and then I'll set my exponents equal to each other. I'll pause for a second while you solve those other three. Let's see how you did on this one. I would have said 3 to the, flip it, -1. Then, this is actually supposed to be an x in there. That was my bad. And so, there we have it. My bases are the same, and now I have 2x has to equal -1. That means x has to equal -1/2. How many of you figured that out? More than half of you. All right, next one. 64 could be made into 4 to the 3rd. Did you know that? 16 could be made into 4 to the 2nd. Then the bases are the same. 3x equals 2, so x equals 2/3. Raise your hand if you had that one right. More people had that one right. Good. And this last one, I would say 5 is a good base for both of them. 5 squared, the x, and 5 to the 3rd. Then 2x equals 3. And that's very similar. It's just now x equals 3/2 is my answer. Who had that one right? Okay, good. All right. The reason these all worked, though, is that we preset them up just right so that they would work. Do you get, all I have to do is change this to a 126, and then the whole thing doesn't work anymore? If you just make one tiny little change, you can't do it anymore. The cool thing about logs is logs could still answer all of those questions, even if I tweaked any of the numbers by one a little bit forward or backwards. It wouldn't matter, because logs can solve any of them. These are only special setup so they will work kind of problems. And a lot of things in the real world aren't that way. When you're figuring out, like, how loud is that sound, it isn't going to be set up just right to come out to exactly 1 decibel. It's going to be like 1.02 decibels or whatever. Okay, so these don't have common bases, so you need logs for them. Now, I showed you on another slide, but it was a while ago. Do you remember how to set this up as a log without going back and looking? Some of you are. Some of you are saying yes. Log base what? Of equals, that's it. You set it up as a log. Now, how would you put that on the calculator again? You don't do log base 2 divided by log base 7. You do log base 7 divided by log base 2. And I'm sorry, I said that wrong. Log 7 divided by log 2. I was throwing the word base around. Log 7 over log 2 is what you do on your calculator to get that. All right. So How about the other one that you never saw before? Try this one. You okay? All right. Yes.
Do you have to write the log 2 7 equals x like as part of your work?
Do you have to write this? Absolutely. That's huge. That's writing it in log form, and that's like the biggest thing is learning how to write things as either exponents. That's an exponent problem. Specifically, it's an exponential because there's an x in the exponent. And this is log form. And going back and forth between here and here, that's like half of your next test. Half your next test is can you go back and forth? And sometimes the problems get more complicated, but it still boils down to, can you take something like this and write the log for it? Would you please try that one? Try the one with the 4 to the x equals 9. Yes? That's a good question. If on this next test, I believe we have it all in one day where part of it's no calc, part of it's with calc. So can't you make it 2 days? Which was really rare that we did a 2-day test like that. So don't expect that that's going to come around again. We have rare partner tests. That was one of the rare ones. I would say between now and the end of the year, there'll probably be another one, but we're talking, they're rare, like once every, you know, like as often as you see the unicorn or you find the, not catching the, what are those little guys with the pot of gold? Leprechaun, because you never actually catch them, but seeing them, I'm sure you've all seen the leprechauns before. Anyway, moving on. Log, that's Skittles, that's a whole different thing. Log base, what? 4 of 9 equals x. There you go, that's it. You've rewritten it as a log. Okay, so how does it get any harder than this? Well, because a lot of times, like this one is not a nice decimal answer. We don't know exactly what it is. But a lot of times, there are ones you can do in your head. Like you can show me a log problem and I can go, oh, yeah, the answer to that one is 6 or whatever. All right, I'll show you a couple like that. I know that one. Answer's 3. And I'm going to show you how you could figure it out in your head. Easy. Okay, so first step. First step is, do you get that there's no x in here? So then you can just say equals x. Second step is, can you go backwards? Yeah, you can make this into one of those x in the exponent problems. So, can you tell me what the x in the exponent problem should be? 2 to the x equals 8. Perfect. And can you do that in your head? I can. 2 to the third is 8. So therefore the answer is 3. All right. So you can do some logs in your head. I'll give you another one. Log base 2 of 1/2. Ooh, a little harder. I know the answer. Well, first step. What is it? Okay, you're right. It's -1. Good. But it's equal to what? X. And then you go 2 to the x equals 1/2. And then you think to yourself, 2 to the what would make it 1/2? And then that's -1. So I know the answer is -1. All right. So the most important thing is being able to take something like this and rewrite it like this, or go backwards and have it something like this and rewrite it with a log. Would you please rewrite that one with a log and be able to say, oh yeah, that's log blah of blah. So, Mr. W, what is it? Log base 5. I'm going to accept your answer, but I'm going to clarify. You need one more little connecting word. Log base 5 of 8. Would you agree if somebody can't say your name right, it just kind of bothers you a little bit? Doesn't bother you? Treant? Doesn't bother you? Okay. So if somebody is saying your name wrong, it's like, that's not the way it's supposed to sound. The same thing happens for math teachers when kids are going, log 510. What? It's not right at all. Log base 510. Well, that's log base 510 is what you said. You know what I mean? Log base 5 of 10. So you got to throw in two little connector words that are like invisible. Like, you know, the pterodactyl where the P is silent. That's why they're so deadly, because you can never catch them going to the bathroom. All right, you figured it out. All right, so log base 5 of 10. They're silent. You can't see them. They're invisible words, but you need to know that they're there. Log base 5 of 10. I can even move the word base above this. Log base 5 of 10. Okay, so we've gotten through a bunch of this stuff by me explaining it verbally. I bet you can do this chart super quick. What's the base in this one? What's the argument? Argument? What? That's the other thing. The base is the little sub number that's on the bottom. Okay, the argument is this, the number that's in that position right there. We could argue about why it's called the argument, but it's called the argument. Okay, so what's the base on this guy? 1/3. What's the argument? And what's the base on this one? 5. What's the argument? 5. We even did square root of 25 in your head really fast, which is good. Okay. All right. So then these are just asking you to rewrite. I've already done a bunch of practice on that. Let's get to this yellow one. So without using a calculator, my advice is say equals x, and then in your head do a rewrite, and then you'll go, oh, so it's really just 3 to the what is 81. And it's not 3, but it's 4 is correct. Because it's 3 to the x equals 81, and you can do it in your head then. I want to give you one hint. The square root of 7, I don't expect you to know the decimal for that. But do you get that that means 7 to the 1/2 power? That will help you get that problem right. See if you can answer all 6 of these. I'm going to pause for a second. Do rewrites. Rewrite them as something to a power equals something else, and they should all come to you. You'll be able to figure out all of them in your head without a calculator. Except maybe one of them. All right, give me one. Which one did you do?
I did the first or the second one.
Which is to the right or underneath?
To the right.
Okay, this one. What did you say?
5 to the x.
5 to the. There's no x. Oh, that's right. I can say equals x. Equals. Perfect. Then you have to make the bases the same. I'd say 5 would be a good choice. So did you make this into 5 to the -2? All right, good. Then what was the answer? X equals -2. Raise your hand if you had that. Okay, good. The next one is row 3, person 2. That's you. What did you do on this one?
I did 8x equals 1.
8 to the x equals 1. I agree with that. And then therefore x has to equal?
0.
Very good. Anything to the 0 power will equal 1, right? So x must equal 0. I know only a few people, I shouldn't say that, more people than, probably less people than the last answer got that right, and that's okay. On to the next one. 7 to the, there's an x over there, 7 to the x equals, this is the one where I gave you the hint, remember? 7 to the 1/2. And once you have that, it's super easy. The bases are the same. X equals 1/2. Would you have known that square root was to the 1/2 power? I hope so. All right. Good question. Did I just square root both sides? No. Just because there's a square root in it doesn't mean I slap a plus minus on it. If I had put a 1/2 power on both sides, then I'd slap a plus and minus on it. Okay, on to this one. There's an x here. 10 to the x equals 10,000. And a lot of kids sadly think, okay, I need to add 3 zeros to this. So I'm going to say x is 1,000. It really makes some sense, but it's totally wrong. Let me give you a hint on this. Would you agree that I can put 1 times 10 to the x? Does that make it scientific notation? 1 times doesn't change anything, does it? 1 times 10 to the what makes 10,000. X has to be what? 4. x has to equal 4. All right, that makes sense. 1 times 10 to the 4th would be 10,000. Therefore, x must be 4. All right, on to the next one. There's an x here. 2 to the x equals negative 4. I hope you looked at that and said, how in the heck am I going to get 2 to turn into negative 4? You can't. No solution. No. I get what you're saying, but if I know you're thinking, oh, I need the square root of a negative, and therefore, if I should be able to say that x is 2i, then you'd have 2 to the second power, which is 4, and then you'd be saying that that was 4 to the I power is negative 1, and then it doesn't work. Now maybe, but what I'd want you to say is that you can't do that. You can't put something to a power and equal negative, and therefore there's no solution. In fact, I'm going to give you a simple way to give a lot of answers right. If this is ever negative, the answer is no solution. It's really simple. You can't have a negative argument. That's called the argument spot. And you also can't have a negative base. If either one of those are ever negative, it's a trick question and there's no solutions. We're not talking you're going to get an extraneous solution. That means I get an answer and then I try it and it doesn't work. It's not that. It's just illegal. You're not allowed to have negatives in your base or argument, either one. That's the base, that's the argument. Not allowed to have negatives in either spot. It's a definition of logs thing. They when they set up logs, they said, we won't allow the argument or the base to be negative, because it would allow for things like this answer, where can you actually get 2 to a power to turn into negative 4? No, you can't. So they didn't want their log system to fail, so they had to set up some rules around it. So if we let people have negatives in that argument spot, there'll be impossible problems. So the definition of logs says you can't have a negative here or here. Okay, on to the exit quiz. So this, 3 of the 4 questions, 3 of the 4 should be easy for you. One of them, I think you're going to probably guess at, but you could stretch and figure it out, and I kind of like that. So it's problem number 2 that's the tricky one. So I'll let you think it through. Pause for a minute while you give it a try. Okay, let's see if anybody figured out number 2. Number 1 shouldn't be too tough. The argument is that spot. Did you say that? Part C, which is S. S is the argument. Okay, good. The next one is the hard one. I'm going to skip it. Go to number 3. Convert that into exponential form. You go 5 to the, wait a minute, there's no x. You say equals x. So 5 to the x equals 8. That would be like that one. A. Who had 3 is A. Okay. Next one, number 4. I don't see an x again. I'd say equals x. And you go 1/4 to the x equals 16. Let me write that. 1/4 to the x equals 16. How do you take a 1/4 and turn it into a 16? Well, first you got to square it. Then you got to flip it. Which one of those says square it and flip it to you? That one. Square it and flip it. And not square root it. That's a really common mistake. You got to take the 4 and square it to make it get to be a 16. So that needs to be a -2. Okay, then the logarithm is, it really wouldn't make sense to say the log is the argument. I mean, that's a spot in a logarithm. The logarithm is a base? No, that's a spot in a log. Then the question is this impossible or is it an exponent? Let me show you something. Would you agree that log, this is a log statement here and it's equal to t, which is an exponent? Because when I rewrite this, doesn't it become r to the t equals s? So if the log is t and t becomes the exponent, the log is an exponent. Did anybody guess that one? Ooh, quite a few of you. Nice. Okay, good. So, your homework for tonight has lots of letters, like problem 1, A, B, C, D, E, problem 2, A, B, C, D, E. And last hour I had them pick, and I'll see if you would have picked the same thing. I was going to let them skip any 2 letters. And at first I suggested like A and C. You could skip the A's and the C's. Okay? They chose instead to skip B's and D's. Do you think that was a better idea, and why? So if I get what you're saying, I didn't give them the option to skip A and B. I was either A and C, because you're right. Every problem has an A and a B. Some of them don't have a C. Some of them don't have a D. But what's the argument for wanting to do the A's? Because they're often easier. Part A is easier than part F, right? Usually. Okay, so what do you guys want to skip? A and C or B and D? I'll let you guys vote. A and C or B and D? Who wants to skip A and C? 1, 2, 3, 4, 5, 6. Can't count twice. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You voting for A and C? 12, 13. All right. Who wants to skip B and D? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Did I say 13 before or 12? I think I'm going to revote because I'm not sure. All right. Do you want to skip A and B, or sorry, A and C or B and D? One last argument on both sides. Want to pause for a second? Okay, so we decided also to skip B's and D's, final decision. So you, on your homework in service class, we're skipping B's and D's on this particular assignment, and do all the rest of the parts, of course. So you just learned logs, and there's one last thought. Logs, a log is a blank. Exponent. A log is an exponent. Logs have bases, and what's the other part to them? Arguments. And you can figure out if the bases are this, you can make the bases the same, that's too easy. But logs can solve them no matter whether their bases are the same or not. All right. So that's your homework for tonight. And let's see. I don't think there's anything else that we need for the video. So that's all I got for the video for today.